Hello, advanced algebra students. Today we are going to look at more linear programming and specific examples from your packet that deal with linear programming. Really, we're focusing on solving real-world problems using linear programming and interpreting the solutions in the context of that situation. So as we continue to work on these, make sure you have your packet handy. Today we are focusing on packet page number 15. This is problem number 1, talking about necklaces and bracelets. It reads, some students make necklaces and bracelets in their spare time and sell all that they make. Every week they have 10,000 grams of metal and 20 hours of work available. So 10,000 grams of metal available, 20 hours of work available. It takes 50 grams of metal to make a necklace and 200 grams to make a bracelet. Each necklace takes 30 minutes to make and each bracelet takes 20. The profit on each necklace is $350. The profit on each bracelet is $250. The students want to earn as much money as possible. What number of necklaces and bracelets should they make so that they can maximize their profit? So the first thing to understand is, what are we looking for, right? The number of necklaces, the number of bracelets that they should make. And so as I set this one up, I think we're going to have, let's see, X. Let's write it underneath. Let's have X equal the number of necklaces, which then means Y will be the number of bracelets. And it's important to understand which one represents which variable represents which item we're looking for, so that as we graph and interpret our graphs, we'll understand which variable is representing which item. So number of bracelets, number of necklaces. Okay, and from that, we've got to try, and it's been helpful to try and maybe come up with a table that'll lead you to understanding how to write these inequalities. And when we're writing the inequalities, we're trying to figure out the constraints to this problem, right? We know that it takes 50 grams of metal to make the necklace, 200 grams to make a bracelet. It takes 30 minutes here, it takes 20 minutes there for a bracelet. But what are the constraints on that? And the constraints were found in the sentence before that. Every week, they have 10,000 grams of metal and 20 hours to work available. Right? So those are the constraints. I can't go over 10,000 grams of metal, and I can't go over 20 hours of work. And so that's going to be our constraints. And I'm going to list them over here on the left. Metal and hours worked. And then we're working with two objects, X for the necklaces, Y for the bracelets. And so this is kind of our table, if you will, that we're using. All right, so how much metal for the X for the necklaces? Well, that's 50 grams of metal and 200 grams for a bracelet. So 200 is going to go over here. Right? Y is the bracelets, X was the necklaces. And how many hours, right? Now be careful here, because it is talking about how many hours. Each necklace is 30 minutes. 30 minutes is a half hour, so half X. 20 minutes for a bracelet. 20 over 60 is really 1/3. Okay? Now over here is where I'm going to list what I call the constraints. Right? How much metal? Well, we know that we only have a maximum of 10,000 grams of metal. So it can equal, or it has to be less than that. Right? I can't go over the 10,000 grams of metal, just like I can't go over 20 hours of work. So I can use that information to write two inequalities. I'm going to work left to right. One inequality for metal, so 50 times every bracelet that I make, plus 200 times every single bracelet that I make, That's for the metal. We have to stay under or exactly at 10,000 grams of metal. Then we're going to talk about the hours that we use. Half hour, so 1/2 X, half hour for every single necklace, plus 20 minutes or 1/3 of an hour for every single bracelet. And I have to be under or equal to, so less than or equal to 20 hours. And then don't forget our last two, X, right? The number of necklaces we make has to be greater than or equal to 0. The number of bracelets we make has to be greater than or equal to 0 as well. Okay, so those are the inequalities that we can use. And again, I'm trying to get those from a table, going back into that story problem. Next step in linear programming is to graph those, all right? To try and graph those so that we can identify that feasible region. I'm going to take that information and I'm going to go and plug it into Desmos, right? So my first equation was 50 times every bracelet plus 200 times every necklace, had to be less than or equal to 10,000, right? 10,000 grams. The next equation was 1/2 times every bracelet plus 1/3 times every necklace. We had to be less than or equal to the 20 hours that we were working. X had to be greater than or equal to 0, and Y had to be greater than or equal to 0. Now, it gets a little bit tricky to see with all of these different colors on here, all right? So I'm going to just get rid of, at least on this graph, the X is greater than or equal to 0, and the Y is greater than or equal to 0. Because hopefully we can see that 0, 0 is going to definitely be a constraint or a vertex of the feasible region. Where do the green and purple overlap? Well, that's this area all in here. So one vertex is over here at 40, 0, 0, 0, right up to here where it's 0, 50, and then 8, 48. Okay. I know that I can't go past the y-axis and past the x-axis because x and y have to be greater than 0. So our vertices, if we take that information, our vertices were going to be 0, 0. We also had 0, 50. We also had 40, 0. And then we had the point 848. So those are those vertices. And it's at the vertices that we can either maximize or minimize the inequalities, right? So we had one down here. If I'm counting maybe by tens, 10, 20, 30, 40, here would be 50. If I'm counting by tens this way, 40 would be like right here. Right, we would have had a line that shot way up here like this. Another line that would have shot, that's not accurate. 8, 48. We would have had another point like right in there. All right, but you can use Desmos to figure out those vertices. Write an equation that's going to help us optimize. Well, in this case, what are we trying to optimize? What are we trying to get the most of or the least of? In this case, maximize the profit. So we have to write a profit equation. P equals how much money are they making? $350 per necklace. Necklace was X. So 3.50 times every necklace plus 250 for every bracelet. So 250 times Y, which was our bracelets. All right, so that is our equation to maximize the profit. So that's what I'm going to put down here. Let's just hide it right above. So we got it out of the way. So using that equation, we need to try and figure out what each one of these vertices from our graph is going to yield for a profit. Okay, so let's go down here and let's test those points, 0, 0. If I plug that in, I'm going to get 0 plus 0, or a profit of $0, right? Meaning, if I make no bracelets and I make no necklaces, I'm going to have $0 profit. What about 0, 50? 0 plus 250 times 50, which is $125, or we get $125, meaning I would make 0 necklaces and 50 bracelets, and I would earn $125 profit. Well, what about 40, 0? 40 times 350 is $140, plus 0 times 250 is 0, meaning we have $140 profit. In context, that means if I make 40 necklaces and 0 bracelets, I would make $140 profit. And then our last one, 848. 8 times 350 is $28, plus 48 times 250 is $128. If we add those values together, I'm sorry, $120, 120. If we add those together, we're going to get a profit here of $148. Meaning if I make 8 necklaces and 48 bracelets, I'm going to get a grand total profit of $148. Hopefully, you can see that this last result would maximize the profit. It would give you the largest profit. Okay. How do I know that it was 8 necklaces and 48 bracelets? Well, remember, every point is listed as X, Y, and on the previous page, we described our X as the necklaces and our Y's as the bracelets. Right? So if we talk about what that means in the context of the problem, if the student makes, let me try and make this a lot smaller. Bear with me for 1 second, please. If the student makes 8 necklaces and 48 bracelets, they would make a profit of $148. That's the maximum they could make. That's the best option that they have, which is why we go through that linear programming process to see which option, which combination in that feasible region would give us the greatest amount of profit. If you have questions, please make sure that you reach out to your teachers. Otherwise, until your next video, everyone, stay safe.